The 7 and 8 talk about filters, right? So it gets very complicated when you talk about capacitor and inductor, and suddenly it jumps into op amps, and then talks about active filters and such. So I actually split it up into two different things that can actually talk about and describes for a whole IDS thing. Is that capacitor and inductor are mainly on high pass and low pass, those filter stuff. However, op amps itself can be applicable for a lot of stuff. It goes back way to ADC, DAC, and then talks about filter, also talk about how to create a voltmeter, ammeter, and such. So in this case, I actually list down all the purpose of op amps and the purpose of capacitor inductor. So in this series of videos, hopefully I can explain well for the passive RC and RL filter. For capacitor and inductor, it can become a sensor, okay, just by alternating its emissivity, area, length, and such, coil number. So these are all things in chapter 3 you can actually take a look. But nonetheless, besides chapter 3, chapter 6 and 7, I think, we'll talk about filters. So before we talk about the filters, so I think basically this video will talk about passive RC filter and passive RL filter to give you a understanding of what they are all about and how they are connected. Because it's very they mix all around in the PDF, which is, yeah, seriously. So the first thing we need to know is actually short circuit. So short circuit itself is allow current to flow freely, meaning if you imagine that if it's short circuit, then this dude over here, it's just a simple wire allowing current to flow through freely. If it's an open circuit, this dude is the difference. So if it's open circuit, this is like open, so then there's nothing to flow through, so nothing flows. So these are the two key things you need to understand first. And then if the frequency increase, okay, XC will become short circuit. What do I mean? If the frequency increase, meaning if let's say this whole system becomes infinity, so 1 divided by infinity is actually 0. So there will be no resistance at all. So the current flowing through this place will be short circuit. I mean, flowing through a capacitor will be short circuit in this case. However, if the frequency increases, for the inductor wise, you actually create an open circuit, which is because a lot of a lot of reactance will be in this inductors. You see, so you actually create a lot of high impedance. So how does this gonna relate to our low pass and high pass? So if you were to remember, this is the low pass graph, and this is the high pass graph with the volt and the frequency, right? So what are these graph all about? So is this graph for this thing, or is this graph for this thing? Yeah. So the graph itself is actually for the R load. So the graph itself is for the R load. So how does this R load and how this graph are being affected by how you place your inductor? So this is what we're gonna talk about. So there is two type of filters. There is a configurations of resistors plus inductor. As you can see, inductor and resistor, You see, inductor and resistors. You see. So for RC means that resistor and capacitance. So there will be resistors and there will be capacitance. You see. Now, if you were to take a look in other sections, if you take a look, if it is the band pass, you're mixing inductor and capacitor already. So it goes a little more hairier. So in this case, what we're gonna do is actually to talk about the RL low pass, RL high pass, RC low pass, and RC high pass. I don't know whether do we have RL high pass, but nonetheless, yeah. So how do we start? So now to start, we're gonna use V equals to IR. You know that V equals to IR can be applied over each of the elements over here. V equals to IR, right? So as you know, in the series circuit, the voltage is summation, right? V1 plus V2 in a series. And then current is the same throughout the whole thing, if you remember. So the voltage is, let's say if the voltage is 5 volt and this is 3 volt. So this means the supply is actually, sorry if I say. So in other words, for example because it is AC, for example it is DC, right? So 1 volt. So if this is 0.5, this must be 0.5 volt. So add up you have a 1 volt. So this is how the voltage works for series. So with this concept we can actually deal with the thing that we're talking about, how low pass and high pass works. So low pass and high pass, if your frequency is high, okay, if you take a look for low pass, if your frequency is high, what will happen? Your inductor, so this is inductor, right? Inductor will become open circuit. Open circuit, in other words, meaning that there will be a lot of resistance. Okay, there will be a lot of resistance. If you remember, XL is equals to 2 pi FL. So if frequency is very high, XL is definitely will be damn high, and the impedance itself will be damn high also, right? The Z total. So Z total times your I, your current throughout the whole thing, you'll get your voltage. So if this resistance is damn super high, and the amount of voltage compared to this one will be much lesser, right? Because if you were to use the voltage divider rule, I think if it's R divided by ZT times I, you get a voltage, right? Voltage of your R at this portion. So if your ZT is damn high, as you can see, ZT is actually this inductor over here. The resistance of meaning this is actually ZT. Okay, so in this case, if ZT is damn high, my fault. Let me repeat again. Damn it. Okay, so this circuit, the whole overall resistance is R plus XL, right? XL contributes from the inductor, and then R is contribute from the resistor. So if you were to use the voltage divider rule, you will get R over multiplied by the current is equals to volt. So in this case, this whole thing is actually some resistance V equals to IR, some analogy lah, okay? So if your XL is super big, okay, if let's put some values in. So if let's say R is 1, and then 1 plus 10, so it'll be 1 times over 11 times I, right? So the voltage is 1 over 11I, while the voltage from the inductor at this point of time is actually 10 over 11I, which is 10 times more than your R load. So your R load itself is actually the one that you connect whatever things here, right? Your whatever, like your rice cooker or whatever, okay? So this is where you connect your load. So in this case, as you can see, if your frequency increase, your inductor gonna eat up a lot of voltage. So in this case, if your frequency increase, what do you see? Your frequency increase over here, your voltage is actually very minimum at your R load. So your R load here is 1 over 11 I only. Okay, in taking that maybe I is actually the current is actually 1. Okay, in this case, if current is 1, so the voltage is only 1 over 11 volt, while this one is 10 over 11 volt. So all the inductor eats up the voltage, while the R load itself is so little. So this explains why the low pass. So this explains how the low pass curve works. So if your frequency lower, if your frequency is much lower, in this case maybe this is 1 and this is 1 and this is like 0.5. So this means that because this one is dependent on the frequency, right? So if the frequency lower, this one will be lower. So this one is 0.5. So 1 over 1.5 I, which is like 2/3. So your R load itself is now 2/3, which is somewhere about here lah, right? So your inductor will take out 1/3 of the voltage. So it's a little I don't know whether is it clear for you, just because it's pretty much very complicated. So in order to make it easier, let me summarize everything. So first thing first, okay, if my frequency is low, okay, so given that XL is equals to 2 pi FL, given my frequency is low, damn low, way too low, you have a very low XL, right, in the inductor. So low XL, meaning that your impedance wise will be very low also. So V equals to I R, right? So this R itself is very low, perhaps maybe XL like you would say, or ZL, whatever. But if this is very low, your voltage will be very low also, right? So if you have a 1 volt over here, your inductor only taking maybe like 0.01 volt, while the rest of the voltage will go to the R load, which is like 0.99 volt. So this explains why at the very low frequency, your voltage is this high. So as your frequency increases, maybe as your frequency increases, this means that your XL is gonna increase a little bit. So if your XL is gonna increase a little bit, your voltage itself gonna increase, because V equals to I times the impedance of the, so you'll get maybe 0.5 volt. So in this case, since this inductor draw more voltage now, this R load will have lesser voltage to take in. So this is why as the frequency increases, your R load voltage is gonna decrease a little. And as the frequency goes all the way, your R load will have nothing to take in. So this is the low pass. But so since with this understanding, how are you gonna filter out all the high frequency? So how does this gonna filter out high frequency? As you can see, if your frequency is damn high, the amount of voltage is very low coming in. So your load will not take in any voltage at all. Will not take in any signals from your source, right? So let's say your earpiece, you will not take in anything that is high frequency at all, because you already filter out through the inductor. So inductor wise, due to the XL, the impedance, is gonna filter out. If it's a low frequency, it's gonna filter out all the high frequency. So all high frequency cannot take in anything at all. So you will not go in, but rather than all the low frequencies will comes in, right? So all the low frequency will comes in. This is only one part of your overall filter lah. If you were to connect a hell lot of filter, right, you would have a different type of things already. So this is just a very small concept of a RL low pass. Meaning if you give in, so in other words, you have a set of signals, maybe V1, right? So this V1 has a lot of V1s. So this or maybe not lah. If so, this V1, nonetheless, this V1 will be connected to a hell lot of filters. Okay, it will be connected to a hell lot of filters. Maybe this will connect to you connect to a hell lot of RL low pass filter. You connect to a lot of RL filter. So perhaps this one will have because individually some will have higher frequency, some will have low frequency. So this is like your music. Okay, so hold on. So if you have to take a look on these things, okay, so this is actually low how do I say, low frequency, or these are all the high frequency. Okay, so in other words, this already acts as a filter. So individually, right? So this thing is equivalent to this one over here, and then this one is equivalent to this one over here. So individually they are all connected. Maybe perhaps not parallel, I think series, I don't know. But nonetheless, they're all connected. So if you have a high frequency only the high frequency. I think they are all connected in series. Okay, they are all connected in series. Sorry, yeah. So they shouldn't be in parallel. But nonetheless, the concept is there, saying that this point of over time, if you set it as a higher frequency or lower frequency, you take in um um lesser signals or what. So this is a key concept that I want to convey on low pass. Okay, I think if I conveyed this well, hopefully this is like conveyed well. So if this is good, so I think you will understand what the hell is high pass. It's just the opposite. So maybe in the later video I'll talk about it. So I'll see you in the next video.